Welcome back to C++ with Miyoshi. Today we're going to talk a little bit about functions. Functions are a nice tool to have for breaking down your problems, and that's really why we want to use functions. We want to break down our problems into smaller problems. We can reuse our code. Matter of fact, if you're going to work in a large group, you're probably using functions. Actually, you're probably using classes, but that's a little bit later in the program, if you will. And then we want to use it for specific tasks. So functions are great to, again, like any type of problem solving, you want to break it down into smaller chunks. Well, functions help you do that. Matter of fact, you've already used a function. This main that we have every time, it is a function. It's got a return, what's called a return type. It's got a function name. It's got these parentheses. It's got these curly braces that you've got, and it's got the return at the end with the 0, which matches the integer. The return, what's called the return type. So let's look a little bit about how functions look. We have every function has a return type. Those return types can be any type that we've had already: an integer, a float, a char, a long, a double. There's other data types that we can use as well. Data types we might even create later on. And we have this new return type called a void. If you don't want to return something from your function, you would use a void. Something like that would be maybe you're giving instructions where all you're doing is outputting to the screen. You might have that as a void type function. So the return type, always very important to make sure you have that return type. If you don't have that, you're going to have an error with your compiler. So we have our function name here, and I have just fn1 for function1. Again, this guy has to follow the naming conventions that we have with our variables. In other words, it's got to be a legal name for a variable, which would mean it has to start with a character or an underscore, and then after that it can have letters, numbers, and underscores in them. There are no dashes or anything like that, any special characters. You can't use those in a function because you can't distinguish between a dash and a minus sign, for instance. Then we have these parentheses. Make sure you have the parentheses. The parentheses tell us that there could be some arguments. Arguments go inside the parentheses, separated by commas. You must tell the compiler what data types those arguments are. Now, these arguments are not arguments that you have with your siblings or anything like that. They are just data that you are passing down to your function itself. Okay? Here at the end of what I call my function prototype, there is a semicolon. Now, this guy here, the whole thing, my return type, my function name, my parentheses, my arguments inside there, and like my main in most cases. Many cases you will not have arguments. Sometimes you will and sometimes you won't, depends on what your function is doing. But that guy there with the semicolon, that's called the prototype. A prototype is very similar to declaring a variable in a function, in your main, for instance. But what it's doing is it's just saying, hey, compiler, I might use this down in other functions, so make sure you know what it is, understand that I am going to define it later. Now, so it's kind of like declaring a function, if you will. Then here in my main, I have this, maybe I have some other code up here that's going to define A and B, for instance, and it's going to give those values. Maybe the user inputs those guys. And then I have this int ans. And notice the int is just declaring this answer. So instead of declaring that up here, I just declared it right when I'm assigning it a value as well. And then I do assign the value function1 a comma b. So this is what's called the function call. And what happens here now is the control, if you will, is going to go to the function. And then whatever happens in the function, whatever happens down there, we don't know at this point in time, but whatever happens to the function is going to get stuck here. And then, because we know it's an integer, and that integer is going to then get assigned to the memory location associated with ants. Well, that's what's called the function call. Now, if you have a void function, you can't assign it a value, or you can't assign its value, return type, a return value to another variable because it doesn't have a return value. But other than that, you should be able to do an assignment for a function, and that's a great thing when you do your function call. Again, whatever the result is of your function is going to get assigned, in this case, to my ants. Now, the last thing is my function definition. My function definition is a repeat of my function prototype. However, there's not a semicolon at the end. No semicolon at the end means that I need to have these curly braces, and that curly braces then are going to tell me what the function does. In this case, all I did was I did a return arg1 plus arg2, and what that does is just going to add these two guys together and return that back. And what happens is those two guys get added together, they get replaced here, and then they get stuck into ants. Now, in this particular one, I didn't really think about this as I was working on this, but if I have A is 3.3 and B is 1.1, if that's the case, these guys here, well, A will go down into arg1, so that would be our 3.3, and our B would be our 1.1. Well, you might think that this is going to return back in here and get 4.4 into my ants, but since arg1 and arg2 are both floats, and they would add up to 4.4, but since my return type is a function, it's going to truncate that guy off, and it's going to be now, ants is only going to have a 4 in it. So, not a very well written function here necessarily, but it does show that 4.4, well actually the 4 would be returned here, and that 4 then would get assigned into ants. So it's kind of like I said, it's that 4 would be here, it would replace that, and then that would get assigned into ants. So functions. Nice way to break down problems. You wouldn't necessarily want to have a function like this that does something that we already know how to do with our operators, but you'd have it do something specific that you're probably going to use over and over and over again in your own code. Similar to a loop in that case, in one instance, but really you're just doing the same thing in a nice compact way. So hopefully you'll use functions. Well, I'm sure you'll use functions to help modify your programs or make them more useful or make them more readable, make them more, I don't know, lots of things, but make them better as you get moving in your programming career or learning. So, thanks for tuning in. Hopefully you come back for more C++ with Miyoshi.